Now that we've discussed division with decimal numbers, we can revisit the transformations between decimal numbers and fractions. And what we want to do is be able to handle the conversion of any fraction, not just the ones that have nice denominators. Well, some of the denominators are still kind of nice. Not completely nice, but kind of nice. And if we wanted to, we could be a little bit clever. Now, if you like being clever, feel free to just follow along. If you do not like being clever, you could just as easily do these examples here by working out a division problem. 5 goes into 4, work that out, put in the decimal point, put in extra zeros. 20 goes into 9, 40 goes into 11. So you can do this with more traditional sort of division problem, or you can be a little bit clever. So just to show you, in case anybody's feeling frisky, in that first fraction we've got a 5 in the bottom. Well, the first nice denominator that we have for decimals corresponds to a 10. I can turn a 5 into a 10 by multiplying by 2. Well, if I do that at the bottom, I do that to the top, and I end up with a fraction 8 over 10, aka 8 tenths, and the fraction name is the same as the decimal name, so 8 tenths as a decimal, 0.8. In the next fraction, I have the number 20 in the denominator, which means that I've already passed that first nice denominator of 10, which means that I'm going to try to take the 20 and turn it into the next nice denominator after a 10, which is 100. In order to turn a 20 into a 100, I multiply by 5. So, multiplying by 5 on the top and on the bottom would end up giving me a 45 over 100. So we would have a 45. The 5 would need to be in the hundredths place, so the decimal point would need to be in front of the 4. And again, if you really like, you can put that 0 in front of the decimal point. The last one's even more tricky, even more clever, you could say, than the others. This is where our knowledge of money comes into play again, as far as the appearance of the 4, and 4 in money connecting with quarters, 4 quarters in a dollar, 4 quarters for 100 cents. So 4 showing up, maybe what I need is something related to a quarter, aka I need a 25. Turns out that's exactly it. There's no nice way for me to turn the number 40 into a 100, which means I would want to try to turn the 40 instead into a 1000. In order to accomplish that, I would have to multiply by 25. If I do that in the top, or excuse me, if I do that in the bottom, I have to do it in the top, which means that we would get a fraction 275 over 1000. Meaning that the 5 would need to be in the thousandths place. In order for that to happen, our decimal point would have to be in front of the 2. And again, if you like, you put the 0 in front of that decimal point for your final answer. This is, again, the clever way of doing things. If you do not like this way of working things out, you can just as well work a division problem for each one of these and come up with those same decimal answers. But so far, all of these decimal problems that we've worked out, converting a fraction into a decimal, and even all of the division with decimal numbers that we've had, they've all been nice, they've all had something in common, and that is, eventually, they've all ended. There have been no more steps in the division process, which means that what we've got would officially be considered a terminating decimal number. At some point, it just stops. Now, by contrast, the other kind that we can come across, I feel like these last two examples that we're going to work, which would be where we would see a repeating decimal. That means that somewhere in our work there are going to be some repeating steps, and we would want to identify as quickly as possible when those repeating steps occurred so that we could say what sort of decimal answer we would have. A little side note here before we actually do these division problems. There's another kind of decimal number, and that's the kind that does not end and does not repeat. And you might be familiar with that as far as the number pi from geometry. The number pi, as a decimal number, never ends and never repeats. So there is that kind of decimal that we might come in contact with at some point in the future. But for right now and for the homework problems related to these topics, we only have these two possibilities. We either get a terminating decimal or we get a repeating decimal. So these last two examples are going to have the repeating sort of decimal situation going on. I'm going to set up our division problem. Fraction 5 over 11. The 11 goes out in front of our long division symbol. The 5 goes underneath. Can't get started until I have a decimal point and at least one extra 0. So I have to put my decimal point in after the 5, put in an extra 0. This gives me enough to work with to get started. Before I actually get into the division questions, I have a decimal in the house, so I raise the roof. Now I go ahead and ignore those decimal points and start working through my division questions and add extra zeros as the case may be. 11 goes into 50 4 times. We get a remainder of 6. Since we're not looking at a remainder of 0, we keep going, meaning that we would have to put in an extra 0, drop that down, and now ask ourselves, how many times does 11 go into 60? 11 goes into 60 5 times. When we do our remainder, we get a 5. So if we put in an extra 0, because we don't have a remainder of 0, we have to keep going. We put in an extra 0, we drop that down, and we're going to ask ourselves the question, how many times does 11 go into 50? Wait a minute. We just answered that question in order to kick things off in this problem. How many times does 11 go into 50? We said 4. So here's where we see the repeating actually showing up. What we've got going on here is a repeating number where the 4 and the 5 in that combination would repeat. Well, this isn't a very efficient way of writing things out, so instead we could try to go with a shorthand version, which is to say, let's try to find a way of symbolizing that the 4 and the 5 together as a chunk will repeat again and again. And what we do to represent that is that we use a bar, and we put that bar over only the numbers that will repeat themselves. Since both the 4 and the 5 repeat themselves in this particular problem, the bar is going to go over both of those numbers. And what we would say here, if we were trying to read this out loud, is that we would have something like 0.45. Now that's what we can read without the bar, but the bar is telling us that the 4 and the 5 are going to repeat, so in words, we're going to actually include that. So altogether, that answer we would try to read out loud and be as brief as possible. So 0.45, 45 repeating. It's not always that we have two numbers that repeat. Sometimes it could be only one number that repeats, depending on what we've got. Shoot, it could be any number of digits that would repeat themselves. So it could be 3, it could be 7, it could be 12 digits that repeat themselves. So I could have small chunks or very large chunks that are repeating. I just keep on working through my division work, A, until I get a remainder of 0, that'd be nice, or B, until I see some sort of repetition. So in a case like this, 26 divided by 75, or the fraction 26 over 75, we want to go ahead and put our 75 out front, put our 26 underneath. go ahead and put a decimal point and 10 in there to get us started. Because we have a decimal point underneath, we have a decimal in the house, raise the roof. And from here on out, we can ignore the decimal point, but we may need to add some extra zeros in here as well, like we did with the previous example. 75 goes into 260. Let's get a little bit more room here. 75 goes into 260 3 times, so that we would have 225. Do a little subtraction here, and we would get 35. So throw an extra 0 in there so that we can keep on going. Either A, hoping for a 0 remainder, or B, hoping to see some repetition. 75 goes into 350 4 times. Get a remainder of 50. Again, throw in an extra 0, try to keep on going here. 75 goes into 500. Well, 75 goes into 500 6 times. We get a remainder of 50. We put an extra 0 in, we drop it down. 75 goes into 500. We literally just finished answering that question 6 times, which means that we're seeing the repetition start. So we have a 0.34666, that keeps repeating on and on. So to try to write that a little bit more briefly, the 0.346, the bar will only go over top of the 6, since that is the only part of this answer that is repeating itself. And again, in words, what we would announce here would be 0.346, 6 repeating. So trying to be clear that the only thing that is repeating is the 6. The 3 and the 4 do not repeat. So here a different example where we have instead just a single digit that's repeating rather than a pair of them like we saw. Again, could have any number, but this is something that I would want to be on the lookout for. Now, because we don't have a way of entering something like this into a computer assignment, we want to make sure we're on the lookout for any sort of rounding instructions that they might give us. And if we get some sort of rounding instructions, we want to make sure that we carry things out far enough that we can do the rounding properly. So depending on what we're told we need to round to, we might need to carry things out several places. We might need to carry things out several places to be able to figure out our correctly rounded answer. So please make sure that you're careful about, again, reading the instructions, and then also make sure you're careful about extending these numbers out far enough that you can do that rounding correctly.